So this is problem 632 from your textbook. It says determine the forces in members EI and JI of the truss, which serves to support the deck of a bridge. State if these members are in tension or in compression. So I wrote out the problem, took a little while to write it down, and then I was just now starting on my free body diagram. And basically, I removed that pin at A. So at A, I'm going to have a AX and AY. And then the roller at G is going to give me a GY. So the first thing, because I do, let's see, or let me write down, or let me circle which one. So we're interested in EI, so that's this member here, and JI, which is this member here. Those are the two that we want to know. So I would imagine this is going to be a method of one that we can use the method of sections. But no matter which side of the method of sections we use, we're going to have too many unknowns. So we can cut through here, right? If we do that, then we have that we know the 5,000 pounds. We don't know what's going on with this force or that force, and then we don't know GY. So it looks like we are going to need to do a little free body diagram of the whole system. So in doing that, I'm just gonna, or we can just use this as the free body diagram. So all we're really interested in is that GY. So just to think about how can we figure out GY, we could sum the forces in the Y direction, but we also don't know AY. In the X direction, we can figure out AX is 0, but that doesn't really help us with the GY. So it looks like we'll have to take the moments. So sum the moments about point A is equal to 0. And for that, we'll do just our typical way to where counterclockwise is positive. It's coming out of the board. So we have that force at B, that 4,000 pounds, and it's 9 feet is the perpendicular distance, and that's going into the board. So that's negative 4,000 pounds times 9 feet minus, and then that 8,000 pound force. 8,000 pounds, and that perpendicular distance, or that moment arm, is 18 feet. And then we have that 5,000 pound force, which is also going to be negative. I'm just going to write it down here because I ran out of room. Is 5,000 pounds times, and that one's, let's see, 1, 2, 3, 4, 5, 9 times 5, so 45 feet. Oh, can't write. 45 feet. And then plus, because I'm doing the right hand rule from A to G, fingers go, so it comes out of the board. So plus GY times that whole distance, which it looks like I forgot to write one of the distances here, but this is also 9 feet. So that's times 1, 2, 3, 4, 5, 6. So 6 times 9 times 54 feet. And that equals 0. And so now we can figure out GY with the calculator. I'm just going to pause it while I figure it out. So I just did the calculation of my calculator, and I get GY equals 7,500 pounds. So now we can take the right side of this section and figure out and do our equations of equilibrium. All right, so I'm just so we're just looking at this right side basically here, and I just copied it over to here. And so what we'll want to do is replace this force here, or let me make this a little bit better. But basically we have this force here, which is the force from I to E. We have this force, which is the force from F to E, and then we also have this force, which is the force from I to J. So we have 3 unknowns. We know GY, so we just figured out it was that 7,500 pounds. So we should be able to do our sum about our forces in the Y and X and in the moments. First thing, it looks like we just have one unknown in the y direction. So I'm going to go ahead and do the sum of the forces in the y direction equals 0. So we have F from I to E is in the y direction. The IJ and the FE are both in the x direction. And we're doing, I guess I should have drawn that. And so then we have minus the 5,000 pounds, and then plus GY, which is at 7,500 pounds, that equals 0. So FIE equals negative 2,500 pounds. So we assumed it was in tension. It turns out we were wrong because we got that negative number. So that means FIE is 2,500 pounds in compression. All right, and then now we need to figure out what's the other two forces. So we have two forces in the two unknown forces in the x direction. So the sum of the forces about x isn't going to help us quite yet. So I'm just going to take I'm going to sum the forces about. It doesn't really matter. I don't think it really matters. I'm just going to do about I, or some of the, I'm sorry, not some of the forces. Let's see. I'm going to sum the moments. Maybe about, I'm not sure that it matters. Sum of the moments about G equals to 0. Yeah, that'll work. Oh no, that's going to give us 2. Yeah, that'll work. So some of the moments about G equal to 0, so we have that 5,000 pound force, so 5,000 pounds. The perpendicular distance to there is 9 feet, and then it's positive. We're doing out of the board is positive. And then we have the FE, which is in line with G, so that doesn't produce a moment. We don't have a moment arm there. Then we have FIJ, which would produce a moment, and that's going to be in the negative direction. FIJ, and that perpendicular distance to there is 12 feet, so times 12 feet. And then we have FIE, which we just figured out was 2,500 pounds, and we found that it's actually going down and not up. So that moment, so I'm just going to change that direction here. That moment is going to be positive. So fingers from G to I and then down. So that'll come out of the board. So that's positive, and that's 2,500 pounds. And then that perpendicular distance is going to be 18 feet. And that's it. That equals 0. And so now we can figure out that Fij. Basically, we'll see, we get 45,000 pound-feet minus Fij times 12 feet plus 2,500 times 18 feet. It's 45,000 pound-feet equals 0. So Fij equals, it'll be that 90,000 divided by 12, which is 7,500 pounds. And apparently we guessed the right direction because it's positive, so that's in tension. And I believe those are the only two we needed, right? We needed the force in EI and JI. So we have EI and JI. So that means that we are done. Yeah, because it didn't ask for the force in FE. We could do that if we wanted to, but since it didn't ask for it, we won't do it. All right.